Hello, scholars. I'm back. Hopefully, you will at least try to do the tree. At least, even if you couldn't do the math, being able to read the problem and setting up your diagram is at least the most important. The math can come along if you can set up your problem. So here we go. Let's start. All right. Let's see what we got. If a person is vaccinated properly, the probability of his or her getting a certain disease is 0.05. Yes, I did not make this problem specifically because of the pandemic we're in. I've always used this problem every year. It just has more significance now. Without a vaccine, the probability of getting disease is 0.35 or 35%. Assume that a third of the population is properly vaccinated. All right. So the ones that are conditions are the first two. So let's highlight those. You're a condition because if a person is properly vaccinated. So they've already helping you out there without a vaccination. So I cannot start with those. I can start with you. Assume that 1/3 of the population is properly vaccinated. So you know that your two scenarios is you're either vaccinated or you're not. So there you go. So that's where we're going to start. So let's go ahead and build our tree. All right. So vaccinated versus not vaccinated. 1/3 of the population is vaccinated. So therefore, 2/3 of the population is not vaccinated. So right there is your first step. You got to be able to find the part of the problem to start with. Okay, so now it's kind of easy. You can just break it off here. You either get the disease or not get the disease, whether you're vaccinated or not. So getting the disease, if you're vaccinated, you're down to a 5% chance. So therefore, not getting disease, you got a 95% chance of not getting disease if you're vaccinated. And so on the other hand, it says you have a 35% chance of getting disease if you're not vaccinated. Not getting disease, 65% chance. All right, so we have our numbers. Now let's actually look at the problems that we have to do. All right, so it says, what is the probability that a person can get the disease? So they didn't say whether they were vaccinated or not. They said just what's the probability of them getting disease? Well, what two branches do I need? Well, I want to use purple. So we need that branch and that branch because we don't care if they're vaccinated or not. It just says what's the probability the person gets the disease. So let's look at the math behind that. Probability of getting disease. That's the first branch. And whenever I cross the branch, I have to multiply the numbers together. So 0.33 times 0.05 plus the disease for the people who are not vaccinated. Well, I have to do 0.67 times 0.35. And so once I do those, multiply them out, add them together, the probability of getting disease is about 25%, no matter what in the population. Just got a 25% chance of getting disease. So that's 0.252. All right, so let's keep going. Let's get to the more complicated problem where we have to do a little bit more manipulation. So let's get to those conditions. If a person gets the disease, so what do I know? I know that the person has the disease. I know they have the disease. What is the probability that he or she is vaccinated? And that's my question. So therefore, this is turned into a conditional. We are looking for the probability of vaccinated given that you know the person has the disease. All right, so therefore, the formula that we're going to have to use is that. So let's rewrite that in formula in the context so we know what math we need. So we need the vaccinated and diseased branch, purple at top. So I'm going to use blue. So we need, oh no, I'm going to use yellow. We need this here because of the people who have the disease, I care about the vaccinated people. So that's going to be the top branch. That's going to be my yellow. But then I need all the people who have the disease. So we're going to go back to, we need all the disease branch 2 at the bottom. All right, so we need you added at the bottom and also you added at the bottom, which is what we just did in the previous section. Okay, so we already actually have that math. We can just drop that number there, but let's go ahead and set it up. So the probability of vaccinated, given that you have the disease, well, that's your branch at the top, the yellow part, and then that's going to be all your disease at the bottom. And you just kind of multiply it out and you divide. And so the probability of being vaccinated and having the disease is that. So there you go. All right, so now let's go to our last example. Example number 3. Again, please try to at least make your diagram. If you can make your diagram correctly, I'm telling you, it'll make the math easier. So here we go. So due to rising costs of auto insurance, the probability that a randomly selected driver, that's probably should be driver, in one city drives an uninsured motor vehicle is 0.13. Knowing that the driver is uninsured leads to the driver's likelihood of being under 30 to be 0.72 or 72%, while the percent drops to 58% for those who are insured. So what is the probability the driver selected at random is uninsured given that the driver is under 30? So that's a lot. We got to figure out where to even start. So what is the one probability part that's not connected to a condition? And I would hope that you would say this right here. The probability that a randomly selected driver, that's supposed to be driver, in one city drives an uninsured motor vehicle is 0.13. That's what we know for sure. So we have uninsured versus insured. So that's what we're going to start our diagram with. Uninsured, insured. Uninsured is 13%, and insured is 87%, because we know 100% of the drivers either are going to be insured or uninsured. So I can subtract that from that 100% or from 1. So now from there, we split up. We have these two categories that can happen in both groups. You could be under 30 or 30 or over. And then they're giving us percentages based off that. So you can be under 30. And they're saying if you're under 30, 72% of the uninsured drivers are under 30. And so, well, the rest would have to be 30 and over. Well, we just subtract that again from 100%, and we get our 28. Then we got to do it again. We got to do it for insured. So they said for under 30, we got 58%. So therefore, the other number is 42. So how I'm getting those numbers, remember, I'm subtracting from 100%. It's got to be that 100% that you got to get to. So now we've set up our diagram. Now let's answer that what question, because that's basically how that works. They're not going to separate it out. They're just going to give you this one question all together. So what is the probability that a driver selected at random is uninsured given that the driver is under 30? So what condition do I know? You know already in advance that the driver is under 30. But you want to know if you have a driver that's under 30, what's the probability that they're uninsured? So, all right, so here we go. So that's the probability of uninsured given under 30. All right, so we know that's what we're looking for. And we know we have to do the conditional math. So let's get the context here. We need uninsured and under 30 branch over, I will change that. You won't be able to see what I see, but it says a probability of return, but I changed it for the video. So that's why I kind of got shot. So it'd be the probability of under 30. All right, so the probability of uninsured and under 30 is, well, we need that branch for uninsured and under 30. So we can easily get that branch right here. Bam, 0.13 times 0.72. But we need all the under 30 people. Everybody's under 30, so we need at least two branches. We need the branch that we already have So we need this branch right here, and we need this branch right here to represent all of our under 30. Okay, so now that we have that, we can keep going, just do the math, and we have our answer. And so that is probability with trees. So you have 4 problems that I think you probably will need help on. Send out Zoom suggestions or whatever when you guys want to meet and get help and tutoring on it. And I'll just walk you guys through, kind of help you out. I hope you stay safe. You only got about a week left. Let's just try to knock this stuff out so you can just be done and you will be a graduated senior. And I'm so excited for you guys. I will miss you guys. I hate not being able to see you guys. I miss my stat kids always. So I will talk to you guys later. Thank you for listening. Bye.